So students, we have already learned three types of charge distributions: linear charge distribution, surface charge distribution and volume charge distribution. The linear charge distribution is nothing but the charge per unit length is called as linear charge distribution, and surface charge distribution is surface charge density is nothing but the charge per unit area is called as surface charge distribution, and the third one is the volume density or volume charge density. It is nothing but the charge per unit volume is called as volume charge density. Now we have to look forward. The next point is electric field. Now question arises, what is the electric field? Electric field is nothing but the point or the charge surrounded by a space, and that space feel the electric force due to that charge. This field is termed as electric field. Electric field is nothing but the field surrounded by the charge, and in that field we experience a certain kind of electric force, and that field is said to be electric field. Electric field is a vector quantity. Electric field is a vector quantity, and that electric field is expressed in the terms of electric lines of forces. These are said to be electric line of force, or electric line of force is always known by electric field line. Electric field line. Now, we know that electric field is a vector quantity. That means for the representation of electric field, we have to specify magnitude as well as direction. So it is called as electric field, and that is given by the letter E. But if in order to express electric field, we express electric field in the terms of electric lines of force. Before that, we say the concept of field was first introduced by Michael Faraday. This is the vector quantity, and that concept was first discovered by Michael Faraday. The electric field is a vector quantity, and the electric field is a characteristic of charge. That is said to be the characteristic of charge. Now, after that, we have to mention about the electric field intensity. Electric field intensity. After that, electric field intensity. For the representation of electric field intensity, we have to specify a certain point, and that point is placed at the field, and we have to calculate the electric, how much amount of electric field is there. So definition or electric field intensity can be defined as the electric intensity at a point in the electric field. The electric intensity of a point in an electric field, that is defined as the force acting per unit charge. Actually here, the point which is placed at the electric field, and that point experiences a force. That point experiences the force, so it is called the force acting per unit charge at that point in the electric field. Force acting per unit charge. By definition of electric field density, what exactly done here? There is a point, and the force is acted on that point in the particular field. So from that definition, we can specify the electric field intensity. So it is also a vector quantity. Electric field intensity is also a vector quantity. Vector E is equal to force upon Q naught, where vector E representing the electric field intensity. Vector F is the force which is acted on that point charge. This is our reference charge. The point charge, and which is placed at that electric field. So we can get the mathematical definition of electric field intensity that is nothing but vector E equals vector F upon Q naught, where the point, where the Q naught is our point charge, and we have to calculate electric field intensity over that point by the definition E equals to F upon Q naught. We have seen that what is the Coulomb force. We know that the value of force. We know that the value of force is given as F equals to 1 upon 4 pi epsilon 0 into Q naught divided by R square. This is the force. If we are considering the charge and reference charge Q and Q naught, this equation we have seen in the last lecture. F equals to 1 upon 4 pi epsilon 0 K into Q1 Q2 and upon R square. This is our previous formula. Here we take it as a reference point. So Q naught is our point charge. It is also epsilon 0 K. So we put this value in this equation. If we are taking it as a vector, then we should have to specify unit vector. Sorry. E equals F, the value of F, 1 upon 4 pi epsilon 0 K into Q naught into Q naught upon R square into R cap as a unit vector. Q naught cancel here. So we have vector E equals to 1 upon 4 pi epsilon 0 K into Q by R square into R cap. This is the required value for calculating electric field intensity. Remember, this is also represented in the vector form because this is the electric field intensity. Sorry. Vector E equals to 1 upon 4 pi epsilon 0 K into Q upon R square into R cap. We repeat again, electric field. What is electric field? Electric field is nothing but a point around which the field, and that field experiences the electric force. And that specific area which experiences the force due to that charge, so that field is called as electric field. Electric field is also a vector quantity. The electric field is first introduced by Michael Faraday. Then this electric field we express we see later in the terms of electric lines of forces. Now, what is electric field intensity? Electric field, that means we know that. What is the electric field? We know that what is electric field. Electric field is that space surround or around the charge. And due to that charge, the force is experienced in that field, particular area. That is the electric field. And if we place any reference charge or point charge in that field, and we have to calculate the electric intensity at that point, so we have the E equal to F upon Q naught. What is meant by F upon Q naught? F means the force. That means to say that force per unit charge, the force is applied on that charge in that electric field is nothing but electric field intensity. And we have for that definition vector E equals vector F upon Q naught. We already mentioned that F, that is the Coulomb force of attraction or repulsion, that is F. F equals to 1 upon 4 pi epsilon 0 K into Q1 Q2 upon R square. Then here we take the point reference charge as Q naught. So we have in terms of that, F is also Coulomb force of attraction or repulsion, 1 upon 4 pi epsilon 0 K into Q naught upon R square into R cap. This is the value of force, and we have to put this value in this equation. So we get vector E equals 1 upon 4 pi epsilon 0 K Q naught into Q into Q naught upon R square into R cap in vector form. The Q naught gets cancelled, so the remaining terms E equals to, E means the electric field intensity, equals to 1 upon 4 pi square 0 K into Q upon R square into R cap. This is the, we say that electric field intensity, and we have, from that formula, we have some dimensions of the electric field intensity, that is m raised to 1, n raised to 1, t raised to 1 and a raised to 1. These are the dimensions of the electric field intensity. Electric field intensity, the dimensions are nothing but m raised to 1, n raised to 1, t raised to 3 and a raised to 1. These are the dimensions of electric field intensity. It is also called, or it is in the presence of dielectric field decreases because 1 by k times value in the free space. 1 by k, this is said to be the value in the free space. So it is electric field intensity. Now we have to specify the equation for electric field due to point charge. Electric field due to point charge, we have already calculated that, that is E equals to 1 upon, E equals to 1 upon 4 pi square 0 K into Q upon R square into R cap. That is, we see that if the electric field due to point charge is spherically symmetric, that is the electric field intensity. Now, the electric field intensity is expressed, we have to express, we know that electric field can be expressed in the, or represented in the lines of force. What is, now question arises, what is electric field lines, or what is electric line of force? Electric field is generally represented in the electric line of force, that is the imaginary path along which unit positive charge can be moved. It is the imaginary path along which the unit positive charge can be moved when placed in an electric field is called as electric line of force. Is called electric line of force. And we know that electric line of force is always known by electric field lines. Now, what is the definition? Electric line of force or electric field lines can be defined as, it is the imaginary path along which a unit positive charge can be moved when placed in an electric field. This is called electric line of force. There are some, we know that there are some properties of electric line force. Electric line of force, these are started from positive charge and aim on negative charge. Electric line of force or electric field lines start from positive charge and ends on the negative charge. The tangent to the line of force, the tangent to the line of force at that point or any point gives the direction of electric line of force. Suppose the field lines, these circular lines can be termed as field lines, and any point, if we draw a tangent drawn at a particular point, that point represents the direction of field lines or direction of electric line of force. Electric line of force. The second, the tangent or the two line of force do not intersect with each other. No any kind of line of force do not intersect with each other. That means to say that they have electric line of force, they have separate existence. They never intersect with each other. The line of force are normal to the surface of a charged conductor at any point. These are said to be normal at particular point at the conductor. These are said to be normal. The line of force do not pass through conductor, hence electric field inside the conductor is always zero. I said electric line of force do not pass through the conductor. That means the total electric field inside the conductor is always 0. And a line of force can pass through insulator. The line of force can pass through insulator. I mean to say that electric line of force do not pass through the conductor. That means electric field inside the conductor is 0. Inside the conductor is 0. But electric line of force can pass through insulator. This is the next. So electric field lines of force are crowded together where the field is strong. Where the electric field lines crowded, we know that where the field is strong, the electric field lines are crowded there where the field is strong and rarely separated where the field is weak. These are largely crowded at the region at which the field is strong, and they are lessly crowded at which the field is less strong or weak. The lines of force under the tension and tend to swing. When these lines of force under tension, they swings, and that is the property we know that gives some kind of nature. This is why explain why two unlike charges attract each other. This is why two unlike charges attract each other. And the last property or assumptions of electric field can be said that the line of force exert lateral pressure. The line of force exert lateral pressure on one another. This explains why the like charges repel each other. This explains the like charges repels each other. These are some points regarding electric field lines or electric lines of forces. We have seen that. Now, the next point is electric line of induction, or simply we can say that line of induction. It is also, line of induction is defined as the path along which a unit positive charge moves. A path along which a unit positive charge moves. But here, one point is different. The field that is placed in a dielectric medium or in dielectric medium other than air. So this is called as line of induction. We have seen line of force. The total, what is meant by electric line of force? It is the imaginary path at which, it is the path along which unit positive charge can be moved when placed in electric field. Here, we see that it is a line of induction. It is line of induction or electric line of induction. It is also a path along which a unit positive charge moves. Unit positive charge moves, but in a dielectric other than air medium. In a dielectric medium that is said to be other than air medium. Here we see that electric induction. Now, these are some points regarding about the theory about the electric field intensity, electric line of force.